Good morning, everyone. I've got the top of the hour, so let's go ahead and get started. My name is Travis Walbeck. I'm the training manager here at NCAT. I want to welcome you to our webinar series we call From Research to Implementation. It's a fantastic program that we have going here where we take some of the research that's been done at NCAT and then invite a guest in that's used some of that to try to help others implement those different technologies and practices into their own processes. So today we've got baselining of balanced mix design mixes for contractors. I'm excited about this one here. Balanced mix design is sweeping the nation and beyond, and contractors that are being proactive definitely have an advantage as they move into the agencies that are going to start to require the balanced mix design testing. It's a good idea to have some sense of where you stand. So today we're going to have Buzz go ahead and be our NCAT representative that presents as well. So not only will he introduce the concept, he's going to be the one that talks about the work that NCAT's done. And then we've got Alex Murphy again from Mid-South Paving, and he's a fantastic partner of ours, has been for many years. And then he is one of those people that we've seen be very proactive about these kinds of new technologies. So given that, I will let's introduce them real quick. Buzz is he worked for the Alabama DOT for 12 years and 2 years in the private sector before becoming NCAT's first test track manager in 1999. He's now an NCAT associate director, and he's also an Auburn University research professor. And then we have Alex. He's worked for over 30 years in the road construction industry. He's been with Mid-South Paving since 1997. And serving in various capacities and primarily in the quality control there. He's currently a quality control manager for Mid-South Paving in the South area. And in our little pre-meeting we had here, we decided he is the smartest man in the room he's sitting in. So we've got that going with him. As always, please send us your requests in the chat box of any questions. We'll try to get to those at the end and answer as many as we can and try to get this thing wrapped up by the top of the next hour. Given that, Buzz, please take it away.
Well, thanks so much, Travis, and I want to thank Alex for helping us again this month in the webinar. He's helped us in the past, and I promised him I'm going to try not to lean on him too much in the future, but we really appreciate him. We've been friends for a very long time, and he was really a foundational participant in the construction of the first test track. So he has a great skill set to share with everybody today. So the content of these webinars, the outline is always the same. I start out with a little bit of background. We typically have one of NCAT's PIs come in and talk about the research that we've done. I'm going to play that role today. As Travis mentioned, we always have a practical component, and Alex is going to share with us his experiences and his perspective, and then I'll come back at the end and put everything together with some takeaways. So make sure everybody knows, in case anyone, this might be your first webinar that you participated in. Everything that we do in these webinars is founded in work that we've done in one way or another at the NCAT pavement test track. That's certainly true with all the work that we've done with balanced mix design through multiple 3-year research cycles. And we finished the first track in 2000. Alex was here when we did that. We've rebuilt every 3 years after that. And there's a unique experiment that is kind of a patchwork quilt of different types of test sections that meet the pressing research needs of our sponsoring agencies and private sector partners with state DOTs, FHWA, and then the companies that come in and buy test sections in partnership with them. And we've really been doing work with balanced mix design for over 10 years. So to give you kind of a view of the background there, my perspective on this is legacy volumetrics for virgin mixes, virgin aggregate blends and neat asphalt binders don't capture anything about binder quality. And this is very well established. And that sort of, for me, is our starting point in any discussion for balanced mix design. If you look back through these past 3-year track cycles, there were only a couple of mixes that had low wrap contents in 2000. The vast majority were virgin mixes. We started doing more work with what I would say were low wrap content mixes in 03. Made a big jump in 06 and 09 to mixes with 45% wrap and 50% wrap. And while we were going through that transition, the extracted PG binder grade of the recovered binder grade from the wrap that we were using in our mixes, it went from the PG 80s to the PG 90s to the PG 100s, and that, I think that has to do with multi-generational wrap, multi-generational recycling. When we mill off roads today, those mixes contain wrap from past generations. So if we don't do anything to use softer binders or to use recycling agents, as expected, the asphalt gets stiffer over time. So in the 2012 track build, that was when we jumped out and started doing off-track preservation research. We called that the PG study. And we had virgin thin lays, and then we had 50% fine fractionated wrap in a thin lay, and then we had a 5% post-consumer recycled asphalt shingle thin lay. And we've learned some significant stuff from that I'll touch on here when I go back to it in just a minute. In 2015, we did more preservation thin lays that were out on US 280. And based on what we had learned from the 2012 cycle and that initial preservation thin lay construction, we went with 11% fine fractionated wrap in combination with 3% post-consumer shingles, and we went through a plant balance mix design process. So we would run mix through the plant in trial mixes and rush it back to the lab, and Adam Taylor would run Texas overlay tester testing, and I think it was Hamburg that we were using at the time to do rutting tests. So we did a balanced mix design process with the tools that we had at the time based on what we were running through the plant. But the big foundation for most of the discussion today is the cracking group experiment that we executed beginning with the 2015 track build. It carried through the 2018 research cycle, where we vetted balanced mix design testing for the cracking side of balanced mix design testing. And what we found was some of the tests worked really well. Some of the to predict performance differences that we saw on the track in a highly controlled experiment, but some of the tests didn't predict well at all. And generally speaking, the tests that were kind of based on the fracture energy or the fracture mechanics of the mix, the brittleness of the mix, those tests did a pretty good job of predicting what we saw on the track and kind of relating to each other. From a practical point of view, anytime we build test sections on the track, or anytime we do maintenance paving on the track, we run side by side volumetric testing with balanced mix design testing, because we think it helps to build our knowledge base and our experience base with what mixes are doing, but also it's a good proof of concept, because if we're going to have the hope to implement BMD testing during construction from a quality control perspective, quality control, quality assurance, then we need to prove that works, and we need to see what that looks like so that we can provide agencies with good recommendations for specification development. So we've been doing that since the summer of 2018, and we're in the process of doing implementation workshops all over the country this summer. Those actually started last week, and there's a huge connection between the economy of mixes, the sustainability of our practices in EPDs and LCAs. Balanced mix design, I think you're going to see is right in the middle of all of that. I think it's very, very important to the future of our practice. So what I want to do is start out just by saying a few words about the thin lays that were high aged binder content that we did over on Lee Road 159. And it's not a current picture. It's actually a little worse than this now. But if you look at the thin lays that we put out there, everything is doing extremely well, except for the 50% fine fractionated wrap thin lay and the 5% post-consumer shingle thin lay. And the reason for that is because in 2012, those were all volumetric designs, and volumetric testing just doesn't tell us anything about the quality of the binder, the blended binder that's in the mix. And this was really the game changer point for me, because all the thin lays look good for a couple of years, and then the two mixes that had the higher age binder ratios from fine wrap and from post-consumer shingles, they really took a turn, and they're still in service now, here after 11 years, but there's a very big difference in performance between these thin lays and all the other thin lays. So Ben Bowers and Suri Gattagani are involved in the workshops that we're doing, and Ben has kind of schooled me up on the triple bottom line. So this is something, because those started this week, I've been thinking a lot about the role that balanced mix design plays in all this. If you think about the triple bottom line, is just kind of how we need to consider people, planet, and profit in sustainability, in our sustainability efforts. And if you think about this, I've actually got some measures here, some examples of how the agency, a metric for the agency and a metric for the industry. So for the agency, there's this thing called the quality of life system, QoLS, and that's a measure of the quality of life for everybody, for the constituents who are using our infrastructure. And then ESI is an employee satisfaction index. So we've got a way to measure. There are measures for the quality of life for people that are using roads, and the quality of life for people that are working in our companies that are building the roads or the industry. For the planet, the agencies are typically going to be focused on LCAs, life cycle assessments. Contractors are going to be focused on environmental product declarations. And then, of course, for profit, the agencies are going to be focused on life cycle cost assessments. And then the industry is going to be focused on profitability. We've got to be turning a profit in order to do this work. So you can, when you talk about the triple bottom line, what folks say is that it's tolerant for some period of time to be in these areas of the overlap in this Venn diagram, but what we really want to be is in the middle. That is sustainable for a long period of time, where we're balancing people, planet, and profit. And in my opinion, balanced mix design is in the middle of that. It is the key to us actually being able to do that over time. So if you look at what we did in the cracking group experiment on the 2015 and 2018 tracks, we looked at a lot of different tests, and the agencies that were sponsoring that group experiment picked what to include. And the test that I think has the lowest hanging fruit for implementation is the ideal CT or the CT index test. And all that is an indirect tensile test where we look at the shape of the curve, the shape of the failure curve, as opposed to peak load off the failure curve, the way we have done in the past. So this is a test that the specification for it has a very, very defined load rate, where if you want to be compliant with that specification, you have to purchase a servo hydraulic machine. But what we have found at NCAT is that there's generally, and I think Texas A&M found the same thing, there's not a statistically significant difference if you use the old screw type presses like this pine press that you see in this picture, which is what we use here at the NCAT pavement test track. If you have one of these old pin plotters, you put a little blue pin in there and you load the sample, and it plots out the load curve, and you just make sure you scale it with the paper that you have so that it doesn't either cut data off or run off so that the load is not accurately represented. So you can run this test hot and look for peak strength off of that curve, and that can be used as an indication of rutting. But you can also run it cool, and you can look at the shape of the curve, and that is an indication of cracking. And so this is very, very viable to do two things, and that's for contractors to use this test to vet their mix designs or to evaluate their mix designs, before they submit them to agencies for approval and use, and then also to use this test during for quality control testing during production. So all the BMD tests that we're talking about today, the ideal CT and the hot IDT, That's just like a dry TSR with a little thinner sample instead of 95 or 100 millimeters. It's a 62 millimeter standard thickness. Otherwise, it's the unconditioned side of a TSR test. And these tests can be run within a 3 to 4 hour window from the time you pull a sample from the back of a truck. And this is because you don't have to heat the mix back up to get it up to an in design compaction temperature, because volumetrics are not part of this. We just need to make sure we compact samples to 6.5 to 7.5% air voids, and there's good tools for us to do that, just like TSRs. And you just have to have enough temperature where you're not crushing rock and changing the aggregate structure. So we can do these tests really, really quickly. So I want to give you a really practical example here. This is a plot just like you'd get from a TSR plot if you've got a pen machine like the one that we have here. So if you look at this curve and then say, okay, here's the calculation for CT index, where the T in this equation is the thickness of the sample. D is the diameter of the sample. T is the thickness. So we're essentially normalizing the results for a 62 millimeter thick specimen. So if you want to take a TSR sample, and when you break it for TSR testing, which is what I advocate to get ready for balanced mix design, if you're a contractor and this is something that's new for you, then you can test a 100 millimeter thick or 95 millimeter thick specimen, and you can run it through this equation. When you do that, what you're looking for is the point on the load curve that represents 75% of the peak load. And what you want to calculate is the downward slope at that location from M 65 to 85. What is the slope across that point of the load curve? And then if you project down, L75 is the displacement at that location, and then that G sub F term is the area under the curve. So this is nothing scary. This is just the same testing that many of us have been doing for TSRs for decades. We're just looking at the curve in a different way. So when you start to experiment with your mixes, and Alex is going to talk about this, but when you look at your mixes and you say, okay, well, my agency is probably going to require a 50 or a 75 or 100 or whatever the number you think is going to be based on how the policy is being developed in your jurisdiction. And you look at your mixes and you say, well, I got a long way to go because my numbers are lower than what are going to be required for my mixes. You got three terms in that equation. So if you're trying to optimize your mixes, what we have found at NCAT is that if you focus on L75 and try to stretch that curve out, it's kind of, we say it's kind of like when the pandemic hit, that they wanted us to flatten the curve, where when you flatten the curve out and stretch out that L75, that if you just focus on that, that's a good way to increase your CT index to try to get to be compliant. So we run this test at 77F. This is the cool test. Run the exact same test, but do it hot in our location. We run it at 122F. If you're in a more northern location, that number is probably going to be lower. But the equation for strength, which is the hot IDT number, it's going to be the same equation that we use for TSRs, and it's all based on the peak load that you measure off that curve. So this is nothing scary. This is stuff that we've been dealing with in our labs for a very long time, and so we just need to kind of look at what we've been doing in a little bit different way. You can, by the way, you can do this manually. If you've got an old plotter like this, you can take these curves and you can kind of approximate the area under that curve, and you can measure all these things that I just talked about without doing anything else. There's also a way that you can take a picture of that curve and you can upload it using WebPlot Digitizer. And when you do that and take a picture, you define the x-axis and the y-axis, and then you define points along that curve. And then using this web page, then you can download data that you paste into a spreadsheet. And we've got a copy of this spreadsheet that's posted out at pavetrack.com/BMD. You can download this page and paste in that data or hand punch in that data, if you just want to pull it off manually. and it'll calculate CT index, and it'll also do a strength calculation for you, so you can use it on both sides of the BMD testing scheme if you want to do that. The easy way to do this is to buy a smart jig, and the smart jig captures that data during the loading process, and then does the calculations for you. But if you just kind of want to get into this without making an additional investment in the hardware, you can do it manually. It's essential in this process, just like it is for TSRs. You need to know how much mix do I compact in a gyratory compactor in order to hit 6.5 to 7.5% air voids at a 62 millimeter height. And there's another spreadsheet that Nathan Moore developed in that BMD folder at pavetrack.com that will help you to hit that target very, very quickly. So I wanted to end up here. This is an example that I've used in a lot of presentations that I've made about BMDs. This is a project that Fan Yin and I worked on together. It was a small project here at NCAT. And it was a project where someone wanted us to take a premium mix additive and put it in a mix and see if it made a difference in the BMD numbers that we measured. Well, when we did that, one of the things we learned was that if you take a mix that's designed on the dry side and then you put expensive stuff in it, you may not see any improvement in these index tests that you would run. So our hypothesis was, well, if we run that same mix through a balanced mix design process and then add the additive, will it make a difference then? We saw that it did, but this is a great kind of an optimization thought experiment to go through with everybody. So this was an Alabama DOT approved surface mix design. The optimized asphalt content is a 9.5 millimeter surface mix. I think it was a 20% wrap, 9.5 millimeter mix. 5.6% was the volumetrically perfect binder content. So we ran the binder content up with this mix. And of course, when you increase the binder content, cracking performance gets better, rutting performance gets worse. And then the zone between what's acceptable, what's desired, and what you can live with, what's desired in cracking and what is acceptable in rutting, that defines what is a balanced mix design. So for this mix, where it was volumetrically ideal at 5.6, we picked a point in the middle of those curves and said, well, but the balanced mix design point for this mix is about 6.1. And there we had an ideal CT of greater than 70. We had acceptable Hamburg test results. And then we actually went back historically and looked at the virgin version of this same mix, even though now it was balanced at 6.1 and it was volumetrically optimized at 5.6. Back when we were running the virgin version of this surface mix, it was actually 6.4 AC. So there's a good historical justification for needing maybe a little more binder in some of these mixes. Now, this is a really simple type of an optimization process that's focused completely on binder content, but you can also manipulate improve your BMD numbers with gradation, with modifiers, with additives, with wrap content and RAS content, and the quality of the wrap and the RAS that you're putting in, and also with recycling agents. All these things are kind of knobs that you can turn in the mix design to change your ideal CT numbers and to verify your Hamburg numbers or your hot IDT numbers in the case of the discussion today. So it's not just about binder content. There's a lot of different things that you can adjust in order to hit your targets. So I also wanted to give you an example, something that's been done on the track, and it's test section N3, which is section number 3 on the north tangent. It's been down now for 16 million easels, and these are reports you can pull down yourself off of the track webpage. There's no cracking, there's no rutting, there's no roughness, and there's no raveling. N3A, the first half of this section, is a 30% wrap, DOT approved mix design. And then N3B is a 45% wrap recycling agent mix design, balanced mix design, and they're equivalent. So you got way more reclaimed recycled material in N3B, but you have equivalent performance. And that's an example of what you can do with balanced mix design when you turn all those knobs. So if you want research this, again, you can go to paytrack.com, which is cross-linked to ncat.us, and pull up the results, the construction data and the performance data for section N3. And if it asks you for a username, you can use Asphalt Research, all lowercase, all one word, with a password of 2018 track with a capital T. So this is a picture from our lab here at the test track, and we've got that old pine press, screwdriver drive pine press that we use for indirect tensile testing. We test at 77 F, as I said, for CT index, where we're looking at curve shape. And then we test at 122 F, where we're using hot IDT to evaluate the rutting susceptibility of the mix. And I just kind of wanted to use this as a turning point to Alex. So Alex, I'm gonna hand off to you now and let you go through your slides. So do you want me to stop my share, or do you just want me to hit advance the slides when you're ready to advance the slides?
I'll just let you do that, Buzz. I'd probably mess it up. But let's touch on what Travis said there at the beginning about being the smartest guy in the room that I'm in. I'm all alone in my room, so that's why I get that. But I like Buzz was saying there, got a lot of different things. In 2019, we had Houston County, which is the county where we live here. They wanted to do something to address the cracking issues that they had on their county roads, and they worked with NCAT and Buzz and decided to use an ideal CT with a minimum of 50 and the hot IDT with a minimum of 17, so we can measure crack resistance and rut resistance respectively. They came up with a one-pager spec that really you had the nominal max aggregate size, which is what we use here in Dothan, and those two numbers, and that was the gist of the specification. Anything else, we could pretty much do what we wanted to with it. Trying to remember, I think we limited it to 35% recycle, but anyway, the idea for the county was that we could put more wrap in it and be able to make a cheaper mix. The next slide there, Bud. And that was sort of the idea. And when we started this process, as Buzz was talking about, we use that web plot digitizer, and I'll talk about that a little bit later. But we acquired a smart jig from Instrotech. We use that in the 850 test press that we had, and we benchmarked our current super pave design. As expected, those designs perform really well in rut resistance, but not too good in crack resistance. When talking with the county, they liked what we used to lay back in the late 80s and early 90s. Our old Marshall mixes, a 416 and a 411, which are surface and leveling mixes. And they were Marshall mixes that had a lot of local materials in them. They had a higher liquid content. They were a lot finer. The texture was a lot finer in them. And they did real well as far as the as cracking. And these roads, the county roads, most of them are farm to market roads. They don't have a whole lot of traffic on them. So rutting really wasn't too much of an issue on those roads, but they didn't crack near as badly. And we ended up having to put in a little bit more crushed particles to enhance that rut resistance. Our BMD procedure, next slide, please. Our BMD procedure that we used with the ideal CT and the hot IDT, we made the 62 millimeter pills. We called them hockey pucks. They're about a third of the height of our normal super pave pills, but we made them at 7 plus or minus 0.5 on the air voids. We aged them for 4 hours at 135 C during design, stirring every hour. And the conditioning time, you could either condition in the water for an hour or in an environmental chamber, which is a fancy name for an oven, for 2 hours. And for the ideal CT, as Buzz mentioned, we conditioned them at 25 degrees C, and the hot IDT was at 50 degrees C. And if you use a water bath at 25 degrees C, they could go in the water as they are. But for the hot IDT, if you use a water bath, you have to use a bag, similar to a core lock bag or something, because the hot water is going to it's going to screw with your results because it really softens up the outside of the pill a little bit too much. Next slide. And we soon, as we started in on this design process, we noticed several interesting things. One of them is temperature plays a very large role. Small variations in the conditioning temperature led to very large variations in the results. We had our oven could not control that closely at the lower temperatures at 50 degrees C as compared to 150 degrees C. It was a lot better controlling there than it was at that lower temperature. And the temperature would waffle between 48 degrees C and 52 degrees, sometimes 53 or 47. And we found this after the fact, after we got some really wonky results on some of our points and didn't get a whole lot of repeatability. We checked it out with our thermocouple here and found that it sort of waffled a little bit. And that's that old, we had VWR ovens with an old hydraulic thermocouple and the dial control, and it just wouldn't really track very well. So I ended up getting it's the Type K thermocouple and a little digital PID controller. And I got those off of Amazon for like $100, whereas the brand new oven with the Type K and digital controller at $3,500 to $4,000. But we ended up getting it to control really closely. Also, timing is very critical because you got the aging time that you've got to worry about as well as your conditioning time. But you also have to worry about your oven space management. Here in Dothan, it's our central lab. I've got 4 ovens that I can make use of. And so having one dedicated to conditioning wasn't that big of a deal. But our satellite labs, we only have 2. And so it's very difficult to try to manage that between just 2 ovens, one for, keeping the samples hot, one for conditioning. And it's just, it gets kind of tough. And the other on timing, the BMD design is an all day affair. You've got 4 hours to condition and then 2 hours 4 hours to age. And you got 2 hours conditioning if you're using an environmental chamber. And so that right there is 6 hours. That's not counting your batch time, your mixing time, your compaction time, and test. So you're looking at least 8 hours, really 7 to 8 hours from the time you start batching the material to the time that you get your results. And it takes quite a while, and that's just part of the test process. Next slide. There you go. And handling with care, the pills that you compact, they're sort of loose. We've got a lot of experience with that here in Alabama because we do TSRs on a regular basis. That's part of the Alabama specs. So we sort of know how to handle them. The idea, we've got a 4140 gyratory big boy Troxler here in Dothan. And so we're able to use our hand jack to jack them out high enough to get our hands underneath the puck. And so we'll transport the pill, the sample with a puck underneath it, set it in front of the cooling station and flip it over after about 3 minutes, or it's about the time you get the next pill gyrated out. And you can flip it over, take it off of the puck, and then remove the paper. If you leave it on there too long, the paper will stick. But, that's a good way to handle them without damaging the samples. Also, sampling is important, which that's sort of should be important anyway, but we made these in 7,500 gram aggregate batches, and because that's about all our mixer would take, and we'd make it up. So we'd make 1 point up in 2 of these 7,500 gram batches. And so as you were sampling, we'd kind of thieve the samples out of the pans, and you can end up, as you're doing that, you can end up segregating your mix very easily. And so you really have to pay attention to that. Super Pave, it's not that big of a deal because you got a 4,900 to 5,000 gram sample. Your pill sample is that large. These are somewhere around 2,500 grams. So you get that smaller sample, things tend to get, you have to be a little bit more, pay a little bit more attention to what you're pulling out, because when you change that gradation structure, if you segregate the mix while you're sampling it, you can end up skewing your final numbers because of that. Once we did our designs and started producing them, we found out a few other things. The short-term aging process that we used, the 4 hours, it didn't really accurately predict the results that we got when we ran it through the asphalt plant. When you age that material, you're driving off the light ends, and you're making that material a little bit more brittle, and that affects your crack numbers, and it also affects your rut numbers. The CT values that we had in production were higher than the designs by several points, and our RT values, our rutters, were a little bit lower than what we had in the design. And that's irrespective of if that's a parallel flow or a counterflow drum. And so we sort of changed our design process a little bit back 2 hours to more accurately reflect what we got in production. Also, there's no time for check samples. We use a nuclear gauge for asphalt content here in Alabama. So if you pull a sample and things are a little bit wonky, you can run out there and grab the next truck in line, put a sample in the nuke gauge to get your AC, and spin a pill out, check your pill height to see if the sample you got was oddball or if that's what the mix is doing. With doing balanced mix design in production, you can't really do that because it takes 3 to 4 hours to run a sample, as Buzz had said. And if you're running 300 tons an hour in a plant, that's 9 to 1,200 tons that you've put out from the time you pull the sample till you get your results. With the county spec that we did, we basically had one sample in the morning and one in the afternoon, depending on how long and how many tons that we were producing that day. And so you did have time for a little bit, but when we did a pilot project for the Alabama DOT, we had to sample our performance samples, our balanced mix design samples, at the same frequency we would our quality control samples, which are 1 every 700 tons. So we were pulling samples before we knew what the results were from the previous sample. So if you had anything wrong, you could end up getting 2 of them back to back that were bad before you had a chance to adjust. And the next slide, please. And one of the things too, that consistency is the key. We all do our QC tests within the bounds of the typically AASHTO specifications or ASTM specifications. When you're bulking a pill, you're using a T166 as a method, and you're operating within that method. And T209 for rice gravity, you're operating within that method, but that method has variability built in, and you can have one guy do it a little bit differently than this guy, and you can still come up with results that are within your precision values. However, on CT index and hot IDT, when you have those small variations, they can tend to be very large variations when you get your results. So we had to kind of follow the same method that everybody was using. I got 2 guys that work for me in here, and I had to make sure that I did it the same way that the next guy did it, and the third guy did it the same way we did it. And that way you ended up with repeatable results. Super pave volumetric testing, quality control, and mix design. There's a lot of forgiveness in there when it comes to temperature or procedure or even some segregation that you can deal with it and still come up with acceptable results that were within precision values. CT index and hot IDT is just, you've really got to pay attention to what you're doing. You need to make sure that you keep your wrap consistent. It's typically with super pave, if you change wraps, you may have to adjust the asphalt content a little bit, binder content. You may have to adjust your gradation a little bit, but the quality, as Buzz was saying, the quality of the binder in the wrap really makes a difference, as well as the quality of the aggregate structure of the wrap. We had moved into a different wrap pile, sort of inadvertently, during the Houston County project, and we got wildly different numbers on our CT indices, it really threw it for a loop. And so you really gotta take care about that recycle, which I'll touch a little bit more about that in a minute. Next slide, please. Suggestions and recommendations. Get an apparatus to test for your performance. There's a whole bunch of them out there. I don't want to say everybody and their brother makes one, but it's just about the case. We went with a smart jig due to mainly its portability. We have a couple of Pine 850 test presses that have the pen and paper chart recorder. I think as far as money goes, the smart jig and the retrofit for the Pine were about the same price, and it was around, I think, between $3,000 and $4,000 if I remember right. You can buy a new machine for somewhere between $8,000 and $10,000, or you can go with the whiz bang Spiff Nito one for $15,000 to $20,000. But if you're just getting into it, you can, as Buzz had mentioned, use that web plot digitizer. It's pretty tedious because it's manual, and it's not ideal, if you see what I did there. But it digitizes that printed curve, and you're able to get the data that's required for the calculations from that. And it does take a while because you have your three CT index samples that you have to scan in, upload, and do all that, and it's pretty time consuming. But I would suggest getting an apparatus. Like I said, the web plot digitizer is not necessarily recommended if you're doing a lot of these. And like I said, ask me how I know. Next slide, please. Make sure that that your ovens can hold temperature very closely. Take you a thermocouple, put it over in there, and put you a sample in, and sort of see how it stabilizes. See where it rests. Like I said, ours with the hydraulic and dial control, they'd waffle, 5 to 6 degrees. You look at it one minute and it'd be 48. You'd look at it another minute, it'd be 51. You'd look at it another time and it'd be 53 or 47. And that 1 degree centigrade, that can really make a difference, especially in your rut pills. If it's a little too hot, your number will be several points lower. If it's a little bit too cool, your number will be several points higher. Same way with the CT index. You're aging or conditioning them in 77 degree, water. And we had left the air conditioner on one night, and our rice water, which is the rice bath, that's where we keep the pills. The rice water was a little bit cooler. And when we ran our tests that morning, that we had some really oddball results, and come to find out it was because the water was closer to 75 degrees than 77. So that can make a huge difference. Retrofitting an older oven is typically a little bit cheaper than purchasing a new one, quite a bit cheaper actually. Benchmark your existing mixes to see where you are. I'd seen a couple of questions in the chat asking about the minimums there, and I think that depends on agency, what they want to do. But your pavement association may have some ideas, or talk to NCAT to see sort of what's the industry standard. Here we're talking about CT index and hot IDT, and they have certain values that go along that correlate to other values with other tests. CT index is, from a cracking standpoint, as Buzz mentioned, is much more straightforward and user friendly than something like the Texas overlay tester, or some of the other ones that require a great deal of preparation of the sample before you test it. But anyway, they all have their own criteria. Understand your wrap piles. Don't just know how much binder is in your wrap and what the gradation is. You really need to look and see what the quality of that binder is. You need to look to see what kind of materials are in your wrap, whether it's gravel or granite or limestone or slag, and look at the crushed faces, the crushed particles in there, and see what they look like. You really got to understand it, and the best way to do it is to put up points with different wraps and see how that affects things. The more rounded particles ought to lead to a higher crack number. The more angular particles will probably lead to a higher rut value. You can send it off to get a recovered binder analysis on the wrap. That kind of it gets expensive. But putting them up in the lab and checking them that way is a good way to sort of see how they come up. You need to make sure you have time. Like I said, the design process to just get one group of results, it's an all-day process. It's not something to jump into if you get rained out at 11 o'clock in the morning and go, hey, we're going to put up some BMD points. Well, that's fine if you feel like being there till about 8 or 9 o'clock at night. But it's something that you really need to plan for if you can. You can have other things going on if you've got the oven space that you can manage, but it needs to be planned out. Next slide. Find a process within the method. Obviously, you've got to stay within your methods to do things the right way, but you need to find a process in there that everybody knows and everybody follows. That, like I said, the small variations can really skew your result or screw them up pretty big. And trying multiple binder contents for each blend, just because you get a at 6% binder, you got this result. If you go up to 6.5, you can't necessarily predict that because this blend is similar to that blend. The curves all look different. You may have one that's nice and pretty and linear across there. You may have one that looks like an exponential curve. So you really, with super pave, you can kind of, if you're shooting for a minimum asphalt content, you can usually try a blend and just get 1 or 2 points and see if it's going to work. It's kind of hard to do that with balanced mix design because the reactions can differ quite a bit. If you do that, get you something that you want to try out, find a customer to where you could try this out in the field. Talk to your customers, sort of explain to them what the benefits could be of this. And if they've got a subdivision or a parking lot that they'll allow you to put that down on, that would be fantastic. You can put it out there. If anything goes wrong or the results don't pass, it's not going to be a terrible thing. It shouldn't fall in. It shouldn't rut and flush real badly. Any failure that you have is probably not going to be seen or really even noticed by the customer. If you've done your design work, you should, just try that out and see what it does. You can see what the differences are in between your production and your design. You can see how it performs in the field, what it looks like coming out from behind the screed, how it compacts. Is it tender? Does it bust up? How workable is the mix? A lot of times with our higher wrap mixes, when we put them out, they're very stiff, and if you have to do any work to them to try to smooth it out, you can see it, and it doesn't work very well together. It doesn't have a great deal of workability, and so it kind of looks a little ugly. And see if that improves, that increased binder content improves that, because it certainly did with ours. And there again, see how that texture looks. If you can translate that from the lab out to the field, that's a very important part of this process to see how it looks. And finally, don't be afraid to try anything really. In the lab, you just I hate to say have fun, but you can have fun just trying finer mixes to see what they look like, coarser mixes to see what they do. What happens when you add rounded particles, a rounded natural sand as opposed to a manufactured sand. See what that does, and you kind of get a gauge to sort of understand when and if this gets implemented by your agency, what you need to do to adjust. Is it just adding liquid to help this, or do add some other product, you increase this product and decrease that one to improve rutting or cracking. You try different PG grades. In Alabama, we use 67 minus 22 for everything except for traffic level easel E range mixes, where we use a polymer. And we don't really change binder grades very much. I know in Florida you run the gamut from time to time, but talk to your supplier and get you a jug of 5228 or 5822 and see what that does. See how that reacts, how your mix reacts to different things. You can try different additives or different products that are design rejuvenators and the like to see what kind of reaction the mix has from that. But one thing I'll say, if you try different additives, you really want to sort of see how they're going to react. So I would recommend doing 4 batches, 2 with your whatever binder that you normally use, and 2 with the binder with that additive in it. Age each for 4 hours, and then the 2 samples at 4 hours, and then 2 samples from 6 to 8 hours, and see the results that you get and how that longer age time affects them. If your rejuvenator or additive, if you get the same results as your neat binder at 6 to 8 hours, that's some snake oil that somebody's trying to sell you a bill of goods. But you need to check that out to make sure that those are worth their while. And sometimes you might find that the mixes that you come up with to fit these criteria, they may be, in fact, cheaper than the normal mixes that you make. They may, but then again, they're probably not going to, or possibly not going to, depending on what your agency is recommending for your minimums. The mixes we were able to produce for Houston County for that specification were in fact cheaper than our surface mixes were. We're able to save the county some money on that, and hopefully producing a superior product. The proof will be in the pudding in several years, but with the Alabama jobs that we did, I believe that our mixes were a little bit more expensive because we had to do more to them to meet higher numbers that the DOT had recommended. But that's pretty much it that I've got. I'll hand it back to Buzz.
Thanks so much, Alex. That's a lot of really good information with what you have there. And while you were talking, I was doing some texting with Nathan Moore. That example that I showed, where I showed how CT index for that particular mix was changing as a function of increasing binder content. And I had texted him to verify this, but as a general rule of thumb, you can kind of guess that when you put 1/10 of AC in the mix, we have really good ways to predict what's going to happen with volumetrics. And kind of on average, 1/10 of AC, you might see a bump of 10 in a CT index, but that's not linear, because when you're on the dry side of the curve while you're adding asphalt, 1/10 might be a 5 bump on CT index, but when you're on the wet side, it might be a 20, and that's definitely gonna vary by mix. That's not universal, but that's just kind of a general observation to share with people. And then I'm sharing my screen, so I was trying not to pull down on the chat that's going on, but Travis had given me a heads up that there's a lot of questions and comments about variability, and we've got to undertake this with with a good understanding of what happens to our numbers when we do different things. Generally speaking, the coefficient of variation for this type of testing is not different than coefficient of variation for other testing that we're doing. But you got to understand that when you age binder through like a reheating process, it's going to change the numbers. So I think as we write our specifications and we think about how to implement this type of thing, we have to have an understanding of that. The focus of this presentation is more for contractors that want to begin to look at their mixes and baseline their mixes. What are they going to run into? But certainly we got we got to understand the variability of what we're looking at. So thank you so much, Alex, for that contribution. Takeaways from this, I'm really sold on getting a higher life cycle value with our mixes using balanced mix design. You know, we have a lot of refining that we can do over time. The threshold values that are selected by agencies, you got to look at your mixes, your binder grades, your aggregates, your mix designs, in order to figure out, you know, what number are we shooting for? Is it a 50 or a 75 or 100 or 125? Do we vary it by traffic level? A lot of questions about how to really pin that down, but we can all agree, all of us can agree that when you get really, when you get significantly low, like CT index numbers, that's a good sign that mix quality is not very good. So we can get better life cycle performance using these practices. When we implement this the right way, as Alex said, we can get more innovation. But we've got to do it. We got to relax the volumetric rules, the volumetric boundaries. So when he's developing mix designs, when a contractor's out there developing mix designs, if I'm a contractor, if the agency tells me, well, we want you to improve your mixes, but we're going to leave all the same volumetric requirements in place while you work to improve your mixes, that's too restrictive. So, I mean, we really, to me, the big question the agency needs to ask itself is, how much are we willing to relax our volumetric boundaries? Because we have a test that's going to tell us if the mix is going to rut. We have a test to tell us if the mix is going to be cracking susceptible. So relax the volumetric boundaries in acknowledgement of that improvement, and we can actually get some innovation. But if I'm a contractor and you tie my hands, you're not really going to get the innovation that you want to get. Alex's experience with that simple, what we call simple BMD specification that's being used in the counties here, I think it's really, really useful. I think he would probably say, jumping into a state project with much more testing and much more rigorous type of a specification framework, the experience in the counties was foundational in his learning curve. But if this is a new thing for you, this is the reason why we're talking about it this month, is you need to be experimenting with your mixes before you bid a job if it has a BMD requirement on it, because you need to understand how your mix is going to react and how much aging you're going to have in your plant. All of the work, the groundwork that Alex did, it's a smart thing for you to do that with your plant and with your project. Some contractors have farther to go than others. You might look at your mixes. There's some single digit CT index mixes out there that have a long way to go. There's teens and 20s that don't have as far, but you still got to do some work. Maybe mixes that we would consider to be pretty good mixes are in the 30s. And if you're looking for a 50 or a 75, you got a ways to go with that, and you need to start working with this. My perception of this is that the industry is cautiously optimistic about this. If we can relax the volumetric specification so that they can actually innovate, it's going to be a good thing. But again, if I'm a contractor and you want to take that first step of implementation and say, well, we like balanced mix design, but we're not going to turn loose of any of our volumetrics, that's going to terrify me if I'm a contractor, because that's going to really limit what I can do. And I recommend that all of us, and I'm speaking as a former agency person who I think has an understanding of some of the things that contractors go through because of the work we've done here at the track, is we need to write our specifications as agencies while we do thought experiments and say, okay, now if I'm a contractor, how would I comply with this? So write our specifications with a consideration for compliance, and sort of do that thought experiment and say, if I'm doing mix designs, if I'm doing QC testing, how hard is this going to be? How possible is this going to be? And I think if we can do that, then that can help us to be much more realistic about the implementation that we're trying to execute. So that was all I had for the takeaways, and that those are all three of our email addresses, Travis and mine, and Alex, and if there's anything else that we can do to help, and we'll Travis will take back over here, and we'll address any other questions that we might have in the chat box. But before we get to that, I always make people aware of the end of cycle conference that we're hosting next year from May the 7th to May the 9th here at the NCAT Pavement Test Track. We want to invite everybody to that. Please note that on your calendar so we don't end up with some accidental conflicts. We always like to recommend everybody take a look at Training in Your Pocket. This is an outstanding series of short and amusing and engaging training videos that Travis and his team have posted out there on YouTube. Where if you have new employees that you really want to get them a crash course, that's a great way to do that. And finally, if you go to LinkedIn, this implementation series, you can register for these at NCAT's LinkedIn page, but you can also register for a kind of a parallel preservation series of webinars that we do. The next preservation webinar is going to be on OGFCs and ultra thin bonded wearing surfaces. So that's going to be really good, and it's going to be focused on our experiences in the NCAT and Menroad partnership. So Travis, with this billboard for the next webinar, which is going to be on our TAC experiences in June, I'm going to hand back off to you so you can manage any kind of Q&A that we might need to have.
That sounds good. We are over time, but I want to get just a couple. You touched on the variability. I think there's a lot of work out there. There's a great report that NCAT did a couple of years ago about a round robin study using IDLT-CT. Found out the sample preparation is absolutely critical. Another question was about load frames and manufacturers. There was a report that was published by AAPT in 2021. The primary investigator on that was Nathan Moore here that Buzz has mentioned a couple times, and he evaluated, I think, 7 different load frames. And so that's a great resource to go look there. I want to thank Stacy Diefender for she put a link in the chat box about some variability research that they've done there in Virginia that we can look at. But Buzz, one of the questions I want to hit with you really quick in here is that I see a question that came up that said, oh man, where did it go? The test temperature for the hot. And I think, where did it go? Okay, would you recommend conditioning the hot IDT specimens at the same temperature you would for running a Hamburg wheel tester?
I think the answer to that question might vary by region. My instinct would be yes to do that. Yeah. But you need to experiment, with your mixes, and what you really want to do is determine that there is a correlation between the hot IDT that you're measuring and the Hamburg number or the APA number that you're also using. So that's where I would start, and if I needed to make some kind of an adjustment to that, then I would be open-minded about making that, because what you really want to do is validate some type of a correlation.
Yeah. So when I did the conversion real quick here, and so if my memory serves me correct, we're testing Hamburg samples here at 50C, and that is the 122 that's recommended on the hot IDT from what you showed in your slides. But I know there's some northern states in the U.S. that are testing at 45 and even some at 40C in their Hamburg wheel trackers. And so that may be, I think your advice is right. Let's figure out where you are and correlate things.
One other comment that I'll make, I'm scrolling back through the chat here, and there's some good comments on variability. There's good comments on the impact of changes that can occur in the binder. And one of the things that we have to keep in mind with this as specifiers when we're developing specifications and enforcing specifications is that if you tell me as a contractor that my minimum is a 50, I'm not going to produce in the low 50s. I'm going to target producing some comfort level that's above that, so that when I run into sampling, testing, variability, when I run into impacts of changing things to my binders, I'm not going to fall out of specification. So like a really important practical thing for us to keep in mind as specifiers is if you tell me to give you 100, you're probably going to get a 125 most of the time. If you tell me that you want a 50, you're probably going to get a 75 from me most of the time, because I'm going to make sure that I produce kind of statistically and materially safely away from the minimum, so I don't get in trouble on that. We don't always think like that as specifiers. I didn't when I was with Alabama DOT, but I think that's a really important thing for us to keep in mind. Like, I don't think we need to be super anxious about some of the impacts of, binder impact and sampling and testing variability, because that's going to be accounted for one way or another in compliance by the contractor. Alex, do you want to make any comments on that?
No, the one thing that I did want to make a comment on there, you talking about volumetrics, that when we came up with our balanced mix designs, our volumetrics were down close to 2% air voids. And with the DOT, that's why I encourage everybody to work with their agency and discuss things like you're talking about with the specifications. That's Alabama said that our target air voids, and say held you to some volumetric ideas, but your target air voids was developed in design. And so what your optimum point was, that was your target air void instead of 4%. But that was the only thing that I had on my brain there.
Yeah, that is one, especially as we move to the higher levels of implementing BMD, releasing some of those legacy requirements is important. Alex, I want to give you just a minute real quick here. Can you, there's a lot of discussion about trying to reduce variability within lab. Can you give us maybe 3 things that you think are the most important, or some of the most important that you found reduced variability for your crews?
Yeah, like I said, the temperature, the temperature that you're conditioning your specimens, getting an oven that can control that temperature really closely, having a water bath that can control temperature very closely, having a heater in it or being able to cool it off. That temperature is a huge deal. The time is a huge deal. How long you're leaving them in there to condition, how long you're leaving them to age. Those have a very large impact as well. And also, as I touched on, consistency, being able to do those tests from the time that you sample them, the procedure you're using to weigh, to how you're getting them out of the water or out of the oven and getting them to the apparatus in order to break them. All that needs to be done the same way by whomever it is that's performing that test. That consistency is just temperature and consistency are the 2 main things that I think that you've really got to have.
Great. Well, thank you. That, given that we've gone well over, we always try to keep this right to the hour and let people get on with their day. So Buzz and Alex, again, thank you both so much. There's a lot of great information here. Seems to me like it's a topic with enough interest. We may need to cycle this back in a few months again. I wanted to put 2 things out there real quick. Thank you, Buzz, for the training in your pocket plug there. Please subscribe to that if you will, and watch, because I think it's tomorrow we're filming one on this hot IDT test. And so that'll be available. It's a quick and easy one. And then I also put in the chat box that another great resource for anything you're looking at with balanced mix design is to go ahead and just Google the NAPA BMD resource guide. There's a tremendous amount of information in there about all sorts of different agencies, all the tests. There's videos for the tests. There's 1-pagers for the tests. A lot of fantastic resources there. So we look forward to seeing you all next month when we talk about TAC codes. And given that, we thank you all very much for your time.
Thanks, everybody. Y'all all have a blessed day. And Alex, we appreciate you coming back this month, man. Thank you.
Yeah.